third segment and three segments. Okay, like that. Nakakaloka. Okay, bronze glory acid. How can we know that? Okay, but before that, before going further, I need to emphasize, guys, the clarity when to say Arrhenius and Lewis in the identification of acids and bases. Arrhenius is very easy. All you have to do is introduce it in a solution, in a chaos solution. When you mean of a chaos solution, that's not referring only to water. As long it is an inorganic liquids, inorganic solvents, liquid. Okay, something like that. Then, you say it is an acid if it will yield H positive ions or H3O, hydronium ions, positive 1. Okay, that's for the acid. And for the base, we need to know the OH negative. In a solution, again, in a case solution, the same shot for both acid and base. And that's for Arrhenius. And now for Lewis, how can we detect? Is through electrons transfer. Electrons transfer meaning to say it could either be an electron donor, an electron acceptor, something like that. Okay? So electron acceptor, okay, through the considering the electrons in the outermost shell during the transferring of electrons, whether it is ionic band or covalent band, okay? So that is Lewis acid. Okay? Electron pair, okay, if you're trying to accept, okay, or acceptor, okay? For example, this is the element will accept the electron. So that is an acid already. You get the point? And for the base, it's the reverse. That is electron pair donor. Okay, meaning he will give something like that. So that's the base. That's identification for Lewis acid and Lewis base. So it depends on the situation. How can you call it is an acid and a base? In different process you will be able to use. But actually, it will fall the same. But the process only is different. Let's prove that later on. And we have the last process in which a scientist known as Mr. Bronsted-Lowry. Okay? For Bronsted-Lowry, I said, here we are focusing for the proton. Proton acceptor and proton donator. Ganon. Okay, meaning to say, somebody has to accept the proton and somebody has to accept or donate the proton. But this is all about elements, compounds, blah, 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 and substances, right? Now, if it is an acid, okay, it will donate the proton. DP, donate the proton. If it is the base, it will accept the proton. We need AP. Just memorize in this way. Okay, acid, DP. Base AP with ADP, BAP. Umana siya sa Bronsted-Lowry. Okay, so that in your memorization, you can easily accumulate that in your brain cells after 2 years, after 3 years, after 4 years, after 50 years, and until your last breath. Okay, something like that. Okay, now in here I have sodium and chlorine. Hala ka mga palangga. Okay, okay. Which among the two will donate the proton? Okay, so that we can say that it is an acid. Okay, now, of course, we need to identify what is really a proton is. Okay, the proton is an element that has a positive charge. The positive charge there represents here in our periodic table the column 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, something like that, huh? So these are the electrons in the outermost shell. Okay, outermost shell meaning the column like that, the column or the group, vertical. Okay, for example, I have here the halide or halogen group. They share the same valence electrons in the outermost shell. We have 7 electrons. For example, fluoride, chloride, bromide, iodide, ganon, right? Iodide and astatide. Wow, 80, the last one, right? So 1, 2, 3, 4, 5. There are 5 members. And they are all highly electronegative. They share the same chemical properties. Okay? Because if that is reflected in the column in the periodic table, that have the same chemical properties. And it depends only now for the atomic number. Okay? Like that. So, proton also, guys, in our very basic chemistry concept, proton is also the atomic number. You get the point? Atomic number. An atomic number is arranged increasing from left to right, from top to bottom. Now let's investigate. I have a periodic table beside my magnetic whiteboard. Okay, so see, 1, 2, 3, 4, 5, 6, ganun, chuba. Ang down po, see, 5, 13, 31, 49, 81, oh, here, 59, 81. So as you can notice, from top to bottom, any column, it will be increasing. Okay, from top to bottom. And from left to right is also increasing. So that represents the proton. Okay, now in this case, we have the same example as before. We will never change for consistency. Okay, we make it consistent in our discussion. Okay, so sodium, we have hydrogen, lithium, okay, sodium, potassium, rubidium, cesium, francium. Okay, these are all having a positive charge, meaning the proton is 1. Positive 1. Or, no need to put 1. That's understood 1. For in case of sodium. Now, chlorine. Okay, chlorine. Now we say that, the electrons in the outermost shell represents. So chlorine is, right here is 7. That is 7 electrons in the valence, outermost shell. But why chlorine has negative 1? It's not 7. Okay, meaning to say, here, in considering the proton chova chocho, okay, we are considering really here that charge. It's not the electrons. So the charge of chlorine, fluorine, bromine, iodine are always negative 1. We are not considering the electrons in the outermost shell or the valence because we are not considering the Lewis dot structure or Lewis identification of an acid and a base. We are not Lewis now. We are now Bronsted, Lowry, acid. So here, proton, chupa, chucho. Okay, now, if sodium will donate proton, because usually he will donate the proton because that is plus. Okay, the more you have, the more you donate. For example, me, I am a very rich individual, and I also try to help somebody is in need in help because somebody to be hospitalized because of chronic diseases, and you have a kind heart and very generous, then you have to give because you have more. The same also here, sodium has more because you have positive proton, whereas chlorine has negative. Sodium must give to chlorine, right? So sodium is our proton donor. But in this case, we are not donating the proton in the humanity, but we are donating money or any kinds of materials, gifts, whatever. In here, we're just donating the proton. I'm just taking the analogy in my discussion, okay? So sodium donating proton to chlorine, ganon. Okay, now this will become sodium positive, ganon, chuchu. Okay, because this is neutral pa siya. They have an inherent charge, but no need to put on the above. Okay, you got the point. Writing by writing, we know lang talaga siya na there's a proton 1, but you don't have to put in the board. After only when it becomes in the aqueous solution, it will become Na+. Okay? The same with chlorine. In our brain cells only, chlorine have negative charge. And if it is in the aqueous solution, it will become now negative. So meaning to say, he is or she is the acceptor of proton. Like that. You get the point? You get the point? Para siya may itabo. Yan yung yun na. You get the point? So, ano siya? So, walang kinalaman dito ang valence electrons in the outermost shell. Okay? Okay. May siya. Klaro siya guys, no? Okay. May mo siya negative. Ganon. So, we can say, sodium is an acid. Okay? And chlorine is our base in this case because we accept the proton from sodium. Okay? Base is chlorine. That's why we attach the sodium from chlorine, become base, right? Nakakaloka. You get the point? Oh, ganon. Any questions so far? Bronze chloric acid is our sodium. Bronze chloric base is our chlorine, like that. Get the point? Okay. It's very clear na. Time check. Okay, mga palangga. Mga palangga kong hitay. Thank you so much for watching this video. We go to another video after this one. If you like, comment, and share, you can do it. If you can subscribe to my channel, that would be good also. You can click the notification bell for some news updates if I am a senior. Eternal voice, bye-bye. God bless everybody. See you later. Ganon. Wait.